So technically combinations include adding, subtracting, multiplying, and dividing. And I don't think the adding, subtracting, multiplying, and dividing are crazy hard, but the notation is weird. Can we just admit real quick? Notation is weird. Okay? So you have to get used to what the notation is saying. The big thing that I was saying yesterday is when you see this, it does not mean multiply. What does it not mean? Are you supposed to multiply? Okay, let's do it a little bit more passionately. What does it not mean? What are you not supposed to do? So are you supposed to multiply? Okay, because you don't use the word times, you use the word f plus g, not times x, f plus g of x. Nah, we can say it better than that. Not f plus g times x, but f plus g. So read this for me. What does this say? Gavin did a great job. Everybody else, where are you? Say it again. What does this say? Do it again. Do it again. Do it one last time. Oh, we did the worst one on the last one? You guys are lame. Okay, anyway. What's the key word? Of. The key word is of. I know it's not like something that you have memorized and you're able to just to recite. But even then, like, have you noticed how bad like the pledges are to the American and Christian flags whenever we have to do it? When did we do it? The opening assembly? Oh, that was awful. That was the worst one I've ever heard. You're welcome, Kyle. I'm just randomly ranting about who knows what. Anyway, who else is absent today? Oh, Angelica's gone. And then, okay. So notation. You got to be careful with notation and have it close. We did an example like it yesterday, but believe it or not, on the test in honors pre-cal, there are going to be kids that do the times and not the of. So why did I have you say it a million times? Because it's a common mistake. Common mistakes can happen in this section. Speaking of common mistakes, this is not easy. Compositions, the idea is not easy. Well, I think it is, but it can be tricky. I'll say that. It can be tricky because you have two different functions. You have an f and a g. And one of them, well, first of all, the notation is just weird. Fog, like what is that? I don't know. But f, little raised, open, dot, zero, thing, g, means f of g or a composition f of g of x. So here's the dealio. What's this little spot mark? Remember yesterday? Not yesterday. Whoa, it's been a lot longer than yesterday. Remember back in function notation, chapter 1a? Remember how I did a box? Right? And why did I do the box? Because I was trying to show you in every equation, the x is just marking the spot for the input. The x is just marking a spot for an input. Who has ever filled out a form online? Ever. Like any document you've ever had to fill in any blanks on a form online. Okay, any form that you've ever filled out on the computer. How do you know what you're supposed to fill out? There are blanks. There are spots shown that you're supposed to fill in. This is just marking the spot to fill in, right? So when you have this guy, f of g of x, when you have fog, I need you every time to rewrite it. F parenthesis g of x. And some of you need to literally put a box around that g of x just to remind you that needs to go in the blank. And whose blanks? Look on the outside. In F's blanks, which is why yesterday I went ahead and put g of x in the box. G of x needed to go in, so it also needed to go in next to the 2. And then I went ahead and substituted the g of x. Now we didn't get to finish it yesterday, but guys, we can do it super fast today, right? How do we finish this problem after we took the g of x and after we put it in the mark the spot in the f function and after we plugged in what g of x actually equaled? Now how do we finish? Distribute the 2. Double check my distribution. Is that good? Give me a thumbs up if you agree. Some of you just trust me and are paying attention. You're cute. Careful, I make mistakes too. All the time. Sometimes in math. Okay, so 2 times x squared, 2 times 2x, 2 times 1. I did not kill a seal. I properly distributed. And then last but not least, I just need to combine like terms. And what's my final? Robert, what's my final answer? Close. Oh, wait. What are you reading right now? That's okay. I'm checking. Oh, you tried to do the example from class. Is that what you were doing? The one we haven't done yet? Erase all that. Okay, so pause. Coming back. Wyatt, what's the final answer? Yeah, and he meant 2x squared. 2x squared plus 4x minus 3. Tony? I have no idea. Do I make mistakes? Some of you not following along as closely as you were supposed to, even after I just said I make mistakes. Ah! Okay, so what's my final answer? Good. Now, this example you didn't even know you had to finish. That's why most of you, like Robert, I didn't necessarily tell you had to finish. I did a ... yesterday. But didn't I just show that even the easy stuff can get hard in this section? The easy stuff, just writing a +1 and not a minus. Anyway. Okay, so we have to be careful of the common mistakes. Let's go ahead and come up to the examples that you guys were looking at the beginning of class. Some of you started, but some of you started it maybe wrong. Bless you, bless you, bless you. What does this little hollow O not mean? Multiply. What does it not mean? Multiply. There's absolutely no new multiplication happening to any of those guys. So here's what I need you guys to do, okay? I need you, underneath each and every one of these, before we even start solving, to go ahead and rewrite. This notation, I mean, to me, I think it totally sucks. I think it just stinks because it makes your brains think multiply. So let's rewrite it in a way that makes sense mathematically. What does this notation show? Who is plugging into who? G is getting plugged into. And the nice thing is we can do it right in order. Who's the big guy? He's the guy that comes first. F is going to be the main function. This little O, I need you to read it as an of. Of G of X. That's the rewritten form, and that's exactly what we showed on the page right before, how to rewrite it. But it's super important that you guys realize it's F of G of X. Now, how is this one going to get rewritten then, using that same type of pattern? G is the big guy of F of X. This one starts to get even a little bit weirder, because as soon as we see numbers, we're like, oh, it's multiply for sure. Nope. Nope. G of F. I love how you guys said of. Okay, so the notation is weird. But the problem is not impossible. I just think it's so much easier in our brains if we write it like this. Now, I want you guys to go ahead and take a second. Just kidding. Take 2 minutes. I want you to do A and A alone. A and A alone. I'm going to freeze the screen. I'm going to do A also. And we're going to see in just a moment whether or not you guys agree with what I do. Do A and A alone using the F of X that's given and the G of X that's given. A and A alone. Yeah. I don't know, kiddo. I'll go look and see if I can fix it. Let me go see if I can fix it. Couple more moments. It's working. Let me just open the door and get some air moving, okay? I also have one of my blinds open in the back. Sometimes letting the sun in just kind of warms everything up. Did you guys get 6 minus x squared as your final answer? Ooh, that's not, well, no idea. Maybe because I turned it off? Does it get brighter when I do that? Oh. Okay. You guys agree with 6 minus x squared? If not, pay super careful attention. Now's not the time just to quickly change it. Now's the time to zoom in and be like, okay, what went wrong? F of who? So what needed to go in the box? G of x. And the box, remember, is just the blank being left for the input. The blank being left is that guy. So when I have f of g of x needs to go in to what used to just be x. And then I can ask myself the question, and some of you do this, like skipping a step or two. And if you're doing it correctly, I don't mind. If you're not doing it correctly, slow it down. Put the g of x in the x box, and who is g of x? Substitution. 4 minus x squared plus 2. Technically, that guy is in parentheses, but question, when there's nothing seen in front of a parenthesis, what's always understood in math to be multiplied? So there's an understood 1. So that understood 1 would distribute, and you would get your 4 minus x squared plus 2. Combine like terms, what's 4 plus 2? Dun, 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 dun. Dun, dun. Got it. Dun, dun. I'll take it. Now, based on how this one just went, go do B. Just B. Go do B. Just B. The order is changed, but the process remains the same. I should say the idea remains the same. P.S. Don't kill a puppy, and if you don't know what that is, look at the puppy rule up on the board. Don't kill a puppy. If it's too far away for you to see. Oh, forgot my square, didn't I? This isn't this problem, but that's how a puppy dies. Try to apply that to this problem. Don't kill a puppy. Dun dun, hopefully. Let's check it and see. Some of you are still working. I'm going to give you a second. I want you guys in your groups really quickly to check each other's work. If you want to switch notebooks, that's totally fine. If you don't, that's also totally fine. Talk it out, talk it out. Does your work line up with theirs? Macy, go ahead and pause and just compare. You don't have to totally be done, just compare. Have you been going the same direction? So what happened when you guys did x plus 2 squared? Did you kill a puppy or did you foil it? Good. X plus 2 times x plus 2. Kathleen, what is it? Plus 4x plus what? Do you guys agree? Because you should, because she's right. Okay. Now, Sam, what were you supposed to do next? I think you have the right idea. What's the word for it, though? There you go. Distribute what? Yeah, you need to distribute the negative throughout the parenthesis. Guess what could have died if you did it too fast? Seal. Poor little seal. Did you guys properly do 4 minus x squared minus 4x minus 4? And then you should have ended up with negative x squared minus 4x, or I suppose if you really wanted to be snazzy and pull out stuff, you could have pulled out a negative, you could have pulled out an x. Could have done all sorts of stuff, but that wasn't really what I was looking for necessarily. But both those answers are right. That's the one I was looking for. Questions? Jade. Oh, I thought you were. Questions? So then how are we going to do C? Plug it in where? There are 2 ways to do it. Let me do this very, very straightforward, making sure we understand everything way. If we're supposed to do all of us all together, f of g of, not 2, I apologize, of negative 2. Thanks, Robert. Okay, how do we think about this? If I'm doing the entire thing. Oh, it's not f of g. What's it supposed to be? Struggle. You guys are trying to do the whole polite, like, Okay. Can we just think like we've been thinking? Who's getting plugged into? F and G, that's true, but who's the big guy? Who's the big one with the blanks that we're putting into? Yeah, G's the big guy. He's the big equation. Over here, F was the big equation. Something plus 2, that's what F told us. G was a big equation. 4 minus something squared. Okay, we did that. This is G also, right? So it's going to be the 4 minus something squared. Who's the something? Yeah, it's technically the f of negative 2, and what I hear a lot of you guys thinking is, wait a minute, okay, so the f guy is the x plus 2 guy, right? But the problem is the x plus 2 guy, isn't he being plugged into also? Right? So we're going to end up with 4 minus, and then we have our f, which is something plus 2. And who's the something that's being added to 2? The negative 2 is getting plugged in. So 4 minus 0 squared, which is just 4 minus 0, which is just 4. Now, some of you, this is a lot more complicated than that one. And why am I even bringing this up? You didn't have to do it this way. You didn't have to do it that way. Couldn't you have done it this way with everything general? Let's find g of f of x, and then what could you have done at the very, very end? Plug it in, plug it in. So you could have technically done the g of f of x, and you could have said, oh, or g of f of x is equal to, what did we get? Negative x squared minus 4x? Then couldn't we have said, okay, let's find g of f of negative 2, which would be plugging in the negative 2 squared and the negative 2, which would have been PEMDAS, square it first, which is a 4, times a negative, which is a negative 4. Multiplication, division from left to right, negative 4 times negative 2 is plus 8. You get the same answer either way. The other way you could have done it is you could have right here been like, ew, gross, and you could have just taken this guy off to the side and said, hey, who are you? Who is f of negative 2? Oh, and then plugged in negative 2 plus 2, gotten 0. You could have actually instead just gone to g of 0, because you could have figured out who f of negative 2 is, substituted, and just been like, oh, yay, g of 0, that's easy. That's 4 minus 0 squared. So there are different ways of doing these ones, especially when there are numbers. You could go plug in and figure out who that is and then just say, take that number and plug in. You could actually like plug in the notation all the way down, or you could plug in or find it generally and then plug in the number at the end. All of them are good. That's composing. F of G of X, or F of G of a number, or G of F of X, or G of F of a number. If you guys were working on homework, though, and you were able to do the compositions and get past the compositions, you might have realized it didn't end at compositions. Where did homework end? Where did the section end? At decompositions. Homework didn't end at compositions. If you looked at the board, there was one more topic underneath. Homework ended at, the section ended at decompositions. Using what we just did with compositions. Decompositions, well, hold on. Decomposing. Do any of your families do compost piles? Super random. No one composts? Oh, Lacey does. No one else does? My friends that moved to Idaho this past summer, they live like up in the mountains. They run a Christian camp up there. But my friend, she and her husband and their kids, they have a compost like box outside. And they just save all their like banana peels and all their like meat trimmings and all their, I don't know, all this stuff. Their eggshells, that one goes in there. They have like their organic matter, and then they have like their trash, and they don't really recycle in Idaho. But anyway, and they just put all their organic matter out in the compost pile. And the compost pile just kind of decomposes. Oh, like little fish they catch that aren't big enough to even worry about. All that's going to just decompose and form like a really good, usually it's like a mulchy sort of thing, not mulch, but a fertilizer. You can use it for other things as well. Where else do you hear decomposing besides like a compost pile? You just put all sorts of stuff in there. Decomposing. Yeah, when something dies, right? Like decomposing bodies, like if you watch like any of the CSIs or NCISs or I don't know, whatever those ones are. Law and Order. That one doesn't have as many decomposing bodies. But, so decomposing, right? What's happening to the body if it's decomposing? It's breaking down. Yeah, decomposition, you're breaking down. The body's breaking down. Or even like with the compost pile, like all those different things are just kind of breaking down. So what are we supposed to do with this guy? If it says to find the decomposition, we're taking a composed function and we're breaking it down into its elemental pieces. We're breaking it down into its elemental pieces or into its individual parts. Individual parts. Well, how many parts does this composition have? Looking at the example. I give you a hint up here. Look at the functions inside out. That kind of helps your brain, I don't know, think through each of the pieces. But how many pieces is this function actually going to break down into? Why 3? It's all because of the name. They've told us it's an f of a g of an h. They could have told us it's an f of a g of an h of a j or something like that. But they told us there's only 3 parts. So our job is to find who is h, who is g, who is f. And if you guys noticed, I went backwards. Who's the inside, who's the middle, and then who's the outside. You can think like little Matryoshka dolls. Ooh, I have an illustration. I usually use these for calculus, but you can think of it, actually. The calculus thing that this illustrates exactly correlates with composition of functions. Little Matryoshka dolls. You know what this is trying to show you, right? The Russian dolls, the nesting dolls, where you have like one on top of the other, on top of the other, on top of the other. Think like an Easter egg that you pop and there's another Easter egg. You're like, ooh, and they keep on going down. Or people who are trying to be really mean for a birthday present and they put a box inside a box inside a box. Okay. So, like, ooh, my birthday present, and it ends up being like, oh, a gift card. Anyway, which is cool. I like gift cards, but, you know. Okay, so the idea is you're trying to think of who's the outside, and then who's the outside, and then who's the outside. So at the very beginning, in this one there's only 3, right? And then there's a little baby one inside who never got colored. Very sad. But coming back. I know, right? It's a rough life. And then the kid who colored him like graduated, and I was like, aw, I'll dang color as well as he can. So, anyway. This one only has 3. So what we're trying to find is who is F, the outside guy, who is G, and then who is H. But what do we have right now? Do we have them all nice and separate? No. They've all been put inside each other. So what we see is this. Now, for Matryoshka dolls, or for these little like Russian nesting dolls, it's easiest to see the outside. And if it's a true one, like you can't even see the inside. You have to break apart the outside. Here's the outer shell, then here's the outer shell. But in math, we don't have to start on the outside. That's sometimes kind of the hardest. We're going to instead look on the inside. So the inside of this function, what's the innermost piece? What's the innermost piece? Okay, you could say x. You could say x. That's not totally wrong, because you could put little parentheses around the x. But are any parentheses around the x right now? No. So you could put parentheses around him, and you could say that he's the innermost. But it might be a little bit easier to look at what we already have. And do we have any parentheses right now that's kind of like trapping anyone inside and inside? I have no idea why that just popped up. Wow, I should care about that. But anyway, coming back. Do you guys see any parentheses? Let's make that H. What's inside the parentheses? Okay. This is going to be our inner guy. X plus 1 is our innermost. That's H. Now, sometimes people can see really easily what G is going to be and then what F is going to be. But sometimes it's easier to think about what's the big picture. So the innermost I see is X plus 1. What's the big picture? Is there anything happening to everything? If you can't see the G, if you can't see the middle, sometimes it's easier to zoom in really close and say, okay, this is the most stuck. It's being squared and it has -2 in the square root. He's the innermost. And then to zoom out and say, is there anything that's happening to everything? The square root is, and we just say square root of x. We're saying what was there before anything got plugged in. So then what's left over? X squared minus 2. Now how can you tell if you did it correctly? Or if you have, there actually are different ways of doing it. Like you could have just made hx, and you could have made the next one x plus 1 squared minus 2, and the next one square root. Or you could have made h of x, x, g of x, x plus 1, and f of x, the square root of x minus 2. Whatever decomposition you do, I think this is the easiest one. This is the most straightforward one. This is the most helpful one in calculus. But how can you tell whether or not your decomposition is right? What should you do? Compose it, yeah. Put it back together and say, does it actually work? Put it back together in the order that it should go. So on this one, if I was to compose it, f of g of h of x. My big pattern would be the f. He's on the outside. What's going inside the f? A g, who's a somebody squared minus 2. But what's going into the input of the g? The h. Does it work? Yeah. But could this guy work just as well? Even though I think this is the preferred one, I think it's the better one. Could this work just as well? Who's the big picture for an f of g of h of x? F is, right? And f says square root of somebody minus 2. Well, who's the somebody? Move in. G. Ooh, this doesn't work. I apologize. Yeah, it should have been a squared minus 2. I didn't write my squared. Because, see, I need that to be squared. So now if I have a somebody squared, there we go. Then can I plug in an x plus 1? Then who goes in the x spot? Oh, just x. You typically don't want a decomposition to have a piece just being x alone, because it's kind of trite. You guys know what trite means? Unnecessary, not helpful, redundant. You try not to have a piece be x, so not that this is wrong, it does work, and it does, well, it didn't work, and I had to fix it. But now it does work. This one is right, and it does technically work, and I wouldn't mark you wrong like on a long answer on a test, but you usually try not to have one of the pieces just be x. It's better when you've like split apart all the different operations instead of having one just be x, so you don't really change anything at the end. But that's okay. So decomposition, what are you doing? You're taking something that's been composed and you're decomposing it. You're breaking it down, breaking it apart. Guys, that's the end of section 1.8. So that homework due tomorrow. I know some of you guys were able to start on it last night. For those of you that did start on it, did you find any word problems in that homework? I don't think there really were. I see a couple of you going to go peek at your spirals. I'm going to have everybody start on their notes 1.9 because we're going to start in this section. Tony's peeking. I don't think there were really any word problems. This one's a very mathy type section. In the sense of very algebraic, just kind of playing with equations. But as you do homework, some of you are like, oh, it's going to be easy. I'm just going to bust it out. Don't have any word problems. Have I at least somehow impressed to you that there are many places where little mistakes can happen? Watch out for the little mistakes. Okay? Watch out for the plugging in. Watch out for the simplifying. Watch out for the distributing of negatives. Watch out for the combining like terms. Watch out for the foiling when it needs to happen. Etc., etc., etc. P.S. You guys see how there are left behind items on the front whiteboard? Typically, if stuff gets left in my room and someone doesn't, like by the end of the day, if it's still there, sometimes people come running in for a water bottle, running in for a book they left under, etc. If kids find leftover stuff, I almost always have them put it up here. And P.S. There's at least one thing that's an honor kid. That's one of you guys. Just pick it up on your way out the door if it's yours. It's actually really, really, really cool. I don't think I usually get to do this. Usually I like bust out section 1.8 all in one day for whatever reason. Oh, yesterday was chapel day. That's why. We didn't get all the way through. It's really cool. We're doing 1.9 right away to begin it at the end of 1.8 because, do you guys see the word notation? Didn't we just talk about in section 1.8 how notation can be tricky? And I made a big deal about, first of all, just the easy operations. You're just adding two things together. But the notation could totally mess you up. And then even if you guys figure out this notation and you actually use your notes when you do homework, oh my goodness, it's amazing. Or you just remember stuff really well, like even if you actually get down to here, and you kind of get the pattern of what the notation is. You might get to something like this, and we talked about how this notation is tricky in and of itself. Because then all of a sudden there's a number, and then a lot of you guys, if you don't think about what's going on, might get totally derailed in the problem. Thinking that there's some sort of multiplication when really that's not at all what it was talking about. And what's the key word that we used over and over and over and over and over again in section 1.8 to try to get you to where you understood the notation? Of. Good. The key word in 1.8 of understanding the notation and understanding what to do is of. And of means plugging in. And plugging in is going into the box or the input of whatever function you're dealing with. Section 1.9, notation is a big deal too. Notation is a big deal too, but not with the word of. With the word inverse. Notation is a big deal too in section 1.9. It's easily confused. Because just like section 1.8 and just like parentheses, which are used in math sometimes to mean multiplication. You've been learning that since what, like middle school? Parentheses sometimes mean multiplication, but in context, does this mean multiplication? No. It's plugging in. Over here, does this mean something other than inverse sometimes in math? Yes. And some of you don't even know to say yes because you're like, well, I don't even know what you're talking about. What's inverse? But what do you see? What word do you see the not of down here? Reciprocal. If you were doing like a pre-algebra problem or even like a math, no, probably not math 7, that's a little hard, or an algebra 1 problem, or an algebra 2 problem, where you were trying to do something like, let me put it in green. This is review, this is old stuff. We have to say simplify writing with positive, it would say something like this, exponents. Something to do with positive exponents. And then if they gave you the expression, let's do 12 x squared y to the negative 3 all over 3 x to the negative 5 y squared. Do you guys remember these expressions, yes or no? Okay, what are they talking about? They say simplify writing with positive exponents, or simplify the expression using positive exponents. What are you supposed to do? Flip it? Flip what? So which ones have the negative exponents? Okay, so then that gets flipped. Oh, so the y squared goes up here, and the y cubed goes down there? No, so many kids do that. Oh, it's such a horrible thing to do. So what do you mean by flipping, Adam? Oh, okay. So then you have the y squared down there already, and then you put a y to a negative 3. Good. So you have to be careful with your wording, right? So you take the y to the negative 3 and realize the negative says put a y cubed in the denominator. So the y cubed goes in the denominator. Does anything else switch spots? Oh, okay. So then the 12x squared stays, but then we also do a 3x to the 5th? No, but you're so close, Robbie. It's a super common mistake. That's not right, but it's half right. Who was actually supposed to move? The x to the 5th. He had a negative exponent. What does the 3 have? The 3 and the 12 are just to the power of 1. So the 3 was supposed to stay down. So then you would go ahead and simplify this to be, hey, 12 is, what, 4 and 1? Reducing the fraction. So I have 4x to the 7th all over y to the 5th. What did the negative powers mean in this problem, this context? Reciprocal. It meant take this guy, take y to the negative 3 and make it 1 over y cubed and then put it in with everybody else. Take this guy, divided by x to the negative 5th and make it times x to the positive 5. In context, these little negative numbers meant you need to flip. But not flip the entire thing, flip this one expression. So from the top to the bottom for y cubed, from the bottom to the top from x to the 5th. But the problem is, this is not the same type of problem. It's a very, very, very different type of problem because it's not talking about individual variables in some sort of expression. It's talking about a function. It's talking about a function. And it's not saying take the entire function to the negative 1 power. If it was talking about the entire function to the negative 1 power, it would not be there. Let me do a quick little aside underneath this guy down here. Okay, let's add a quick little note. Notation for raising functions to powers. Not that you really ever do it, but raising functions to powers, because that's when you guys will get confused. If you see that little f negative 1 of x, which we aren't even going to say negative 1 at any point past today, I'm just going to always call it f inverse of x, like you guys wrote in your notes. You're confusing it as a power if you're thinking of flipping. So if you ever want to raise a function to a power, you would have to write it on the outside. I'm going to put an n because it could be squared, it could be cubed, it could be to the negative 4th power, the negative 5th power, the 1/2 power for a square root. If you ever wanted to raise a function to a power, you would have to do it on the outside of the whole thing. But what's going on with this -1 that you see up here in the notation, guys? It's not on the outside. Where is it? On the inside. And on the inside does not mean powers. On the inside means inverse. So when you read this entire section, 1.9, whenever you see it in homework, whenever you solve for it, whenever you write it down, whenever you write down the directions and problems and it's there, never say f to the power of -1, because that's not right. It's on the inside. It's not f of x raised to a power. It's f, what did I say? Inverse. Okay? It's f inverse of x. So after all of that work, and it's just notation. So what's the inverse again? Here he is. All of that was just notation, so you guys don't get confused by that little -1. Now let's talk about who the inverse is. Definition of the inverse. Definition of the inverse. And what I have in the circle is just like a little hint. It's like, hey, use this to test the functions to see if they're inverses. I think homework starts off, or at least it comes up pretty quickly. Are these functions inverses? We'll give you 2 and you tell us whether yes or no they pass or fail for being inverses. This is how you test them. Take a composition of one inside the other, everything, every addition, every subtraction, every power, every root. Everything should cancel out, reduce away, be gone except for the x. Or plug in the other direction. Plug in the first function into the second function. And every plus, every minus, every times, every divide, every square root, every power should cancel away except for the x. An inverse, here's my key, and I don't think I write it anywhere else. I might. Is the grand old undoing. It's the grand old undoing of a function. An inverse is a function's undoing. And what I mean by that, you guys know an undo button, right? Use it a lot probably in like word processing or in like, especially if you're doing something like DigiPhoto, you don't like what you did. The undo button. Life is very sad when the undo button isn't allowed to be clicked and you're like, oh, I didn't mean to do that. Sometimes in life we wish we have an undo. There's some movie like that, like Adam Sandler with Click or Remote Control, or I don't know. Anyway, undoing. I'm not saying it's a good movie, I don't even remember it. Undoing. You're undoing each operation, each addition, each subtraction, each multiplication, each division, each square root, each power. You have to undo it, but you have to undo it in a proper order or else it's not going to work. So you're undoing everything that's been done to the x and getting back to the x alone. So the easy way to do this grand undoing is to take the original function, to switch the x and y and solve for y. And when you solve for a variable in a different spot, you're going to have to take away, undo, take away everything that's being done. But here's the key for domains and ranges. If the solving procedure is to switch x and y, then solve for y, I'm going to add one quick naming the new function f inverse of x. Naming the new function f inverse of x. You can't just call it y, because y equals was the original function. You have to take the new y and call it f inverse of x. Switching x and y is going to switch the domain and range. So the domain of f is going to become the range of the inverse. And the range, all the y's of f, are going to become the domain of the inverse. It's perfect timing, because I didn't want to get to the next page anyway. So we have the idea of the inverse, the notation, and the quick little reminder, something about switch x and y, solve for y. We'll see it tomorrow. Tonight, compositions of functions. Bust it out, cool kids. I'll see you tomorrow.